Underwater welding. It's one of the most essential jobs on the planet. When an oil platform, underwater pipeline, dam, or even ship needs repair, a select group of men and women are called on for this special task. It can be an incredibly dangerous line of work. So what does a day in the life of an underwater welder look like? Well, it depends on where the job is. Underwater welders who work inland start their day pretty much the same as any other person. They get up, get ready, then head off to their workplace, which could be at a lake, river, or dam. Common tasks here include salvage, rescue, as well as the maintenance and repair of facilities such as docks. Once they've rendered their 8 hours at work, they're free to go home. But for any underwater welder working offshore, it's a very different story. They may spend months at a time deployed at sea to oil platforms or large marine vessels. Due to the essential nature of their work, they often work grueling hours too. Offshore underwater welders might work an 80-hour work week, but exhaustion is often the least of their concerns. Once underwater welders descend into their work sites, which can go as low as 1,300 feet, they risk never making it back to the surface. Risks commonly associated with diving, such as decompression sickness, hypothermia, or drowning, aren't even the most dangerous parts of the job. Yes, drowning. No matter how much training or experience an underwater welder has, the risk of drowning is always going to be lurking around the corner. This is due to delta P, or differential pressure hazards. That's when two bodies of water of differing water levels intersect and create a massive pressure difference, generating huge amounts of force, up to hundreds of pounds of pressure per square inch. If the connection between the high pressure and low pressure bodies of water is small, the diver can get trapped in the bottleneck of the flow and drown. Underwater welding at temperatures of 10,000 degrees Fahrenheit and above causes the hydrogen and oxygen in the water molecules to separate. If the proportion of hydrogen to oxygen reaches a certain level, it can lead to an explosion. Even minor explosions have enough force to result in fatalities due to the water density and the danger of shock waves. Underwater welders also face the risk of electrocution, so they've developed a dry welding method to mitigate that risk, as well as perform higher quality jobs. In dry hyperbaric welding, the weld is performed at raised pressure in a chamber filled with a gas mixture and sealed around the structure. These purpose-built chambers allow welders to work underwater in a safe, dry environment. A system of fans continually exhausts and brings air into these chambers, along with a gas, such as a mixture of helium and oxygen. This mixture allows the interior of each hyperbaric chamber to maintain relatively high air pressure, which helps prevent welders from getting decompression sickness while on the job. But hyperbaric chambers take time to set up, can be quite expensive, and aren't generally reusable. This means that when urgent emergency repairs are needed, underwater welders have to resort to what's known as wet welding. In underwater wet welding, the cables are double insulated and only direct current is used as a power source. Waterproof electrodes have a thick material called flux on their outsides. As the electrode burns, chemical changes produce a gas bubble around the arc which protects the weld. As the diver moves along the seam, they leave behind a metal liquid called slag. It covers the top of the seam so that the weld has time to cool properly. Underwater welding requires not only a high level of skill, but nerves of steel. Until robots are able to perform tasks with the same amount of precision as people on the job, underwater welders will continue to play a crucial role in maintaining the world we live in today.